Square Roots, Part 2. In this module, you will learn about finding square roots by division method, square roots of decimals, and estimating square roots. Prime factorization method can be useful to find out the square root where the numbers are a bit large. But when the numbers are larger, we cannot find out the square root easily with prime factorization. So to find out the square root of large numbers, we can use long division method. Look at the table. The perfect square numbers like 100, 961, which is in 3 digits, have the square root in 2 digits. Also, 1024 and 9801, which is of 4 digits, also have 2-digit square root. We can say that if a perfect square is a 3-digit or a 4-digit number, then its square root will have 2 digits. Also, you can observe that the smallest perfect square of 3-digit is 100, which is the square of 10. Further, the greatest 3-digit perfect square is 961, which is the square of 31. Similarly, the smallest 4-digit perfect square of 1024 is 32, and the greatest perfect square of 4-digit is 9801, which is the square of 99. Now, can you tell the number of digits in the square root of a 5-digit or a 6-digit perfect square? Well, to find this easily, just remember this. If a perfect square is of n digits, then its square root will have n by 2 digits if n is even, or n plus 1 by 2 if n is odd. Therefore, the number of digits in the square root of a 5-digit or a 6-digit perfect square is 3. Let's find out the square root of 3-digit number by division method. Let's understand with an illustration. Find the square root of 576. The first step is to put the bar over every pair of digit starting from ones place. If the number of digit is in odd, then we have to put the bar on the left single digit too. Step 2. Now we have to find the largest number such that it is equal or less than the number under the extreme left bar. Here you can see we have 2 as the divisor for the dividend 5, for which we get quotient 2 and remainder 1. Step 3. Now bring down the number 76 next to the remainder. So now the dividend becomes 176. Step 4. Now we need to double our divisor here. It becomes 4 as a divisor. Step 5. Place a blank space next to 4 here, for which we need to guess the largest digit to fill the blank, which will also become the quotient, such that when the new divisor is multiplied to the new quotient, then its product will be equal to or less than the dividend. In this case, if we multiply 43 into 3, we get 129, or 44 into 4, we get 176. So we choose the new digit as 4 and calculate further. Step 6. Since the remainder is 0 and no remainder is left out, so we can say that the square root of 576 is 24. Now consider square root of 5329. Place a bar over every pair of digits starting from the ones digit. Then find the largest number whose square is less than or equal to the number under the leftmost bar. Now, take this number as the divisor and the number under the leftmost bar as the dividend. Divide and get the remainder, that is, 4 in this case. Now bring down the number under the next bar, that is 29, to the right of the remainder 4. So the new dividend is 429. Now double the divisor and enter it with a blank on its right, that is 14 and a blank. Now guess a largest possible digit to fill in the blank, which also becomes the new digit in the quotient, such that when the new digit is multiplied to the new quotient, the product is less than or equal to the dividend. In this case, we see that 143 into 3 is equal to 429. So the new digit in the quotient is 3. Since the remainder is 0 and no bar left, therefore square root of 5329 is 73. Now for estimating the number, we used bar to find the number of digits in the square root of a perfect square number. In both the numbers 576 and 5329, there are 2 bars, and the number of digits in their square root is 2. Now can you tell the number of digits in the square root of 66,049? By placing bars, we get 66,049. Since there are 3 bars, the square root will be of 3 digits. To find out the square root of the decimal numbers, we need to follow same division method. Just placing of bars is slightly different in this case. Let's learn it with an example. Find the square root of 7.29. To find its square roots, we will go step by step. Step 1. We will put bars on the integral part, that is on 7, in a usual manner, and we will place bars on the decimal part, that is 29. Step 2. Now we have to find the largest number such that it is equal to or less than the number under the extreme left bar. Here you can see we have 2 as the divisor for the dividend 7, for which we get quotient 2 and remainder 3. Step 3. Now as done before, also bring down the next bar, that is 29, to the right of the remainder 3. Step 4. Double the divisor such as 2 will become 4 and with a blank on its right side, and as we know 29 is the decimal part, so we need to put the decimal point in the quotient after number 2. Step 5. We can see here that 47 into 7 is equal to 329. So the new digit will be 7, and by dividing 329 by 47, we get 0 as remainder. Step 6. Thus, as no remainder left, so we can say that the square root of 7.29 is 2.7. Consider a larger number, 390.625. To put bars on both integral part 390 and decimal part 625. Remember that for 390, we start from the units place, close to the decimal, and move towards left. The first bar is over 90 and the second bar over 3. While for 625, we start from the decimal and move towards right. That is, first bar is over 62 and second bar we put on 0 after 5 and bar on 50 to make it point 6250. Then follow same method to solve or find its square root, placing the decimal point while shifting decimal integral down. Now we will learn how to find the square roots if only situations are given to us, with few examples. Suppose the area of the square has been given as 441 meters square, and we need to find the length of a side of a square. Or Sheila and Rita played a game. One told a number and other gave its square root. Sheila started first. She said 25, and Rita answered quickly as 5. Then Sheila said 81, and Rita answered 9. It went on till at one point Rita gave the number 250. And Sheila could not answer. Then Rita asked Sheila if she could at least tell a number whose square is closer to 250. In all such cases, we need to estimate the square root. We know that 100 is less than 250, less than 400, and square root of 100 is equal to 10, and square root of 400 is equal to 20. So 10 is less than square root of 250, less than 20. But still we are not very close to the square number. We know that 15 square is equal to 225, and 16 square is equal to 256. Therefore, 15 square is less than 250, less than 16 square, and 256 is much closer to 250 than 225. So, square root of 250 is approximately 16. Similarly, we know area of a square is equal to length square. Therefore, length of each side is equal to square root of 441. Therefore, assuming number whose square is near to 441, we get 441 is near to 400 or 20 square. As 441 is greater than 400, so we'll check 21 square. So we get 21 square is equal to 441. Bingo! Therefore, we can say square root of 441 is 21. Similarly, estimating square roots in this way helps us to find the square roots in rapid and easy way. Let us revise all the topics we have learned in this module, Square Roots Part 2.